Yeah, I think I'm live. Let's discuss about today's biweekly contest. Stream December 7 stream. Okay. Created a folder. Let me share my screen. Yeah, hope my screen is open. Just about stream. Yeah. So it's biweekly 171, right? Let's see the first question. So I was able to solve the questions 1 and 3. Yeah, this is a good contest. And I think I solved till last minute. Try to solve problem 2. I took more than half an hour, but I couldn't finish it within the time. But yeah, we can see the questions. The question is complete prime number. So let's see the question. You are given integer num. You'll be given an integer, and if it's called a complete prime number only if these things are satisfied. So a prefix should be prime number and suffix should be prime number. We know the definition of prime number. Single digit numbers also considered as prime number. So basically the number can be of any digits, so it can be any digits. Why is it still not stopped? Okay, somehow timer got set. So yeah. So the question says given an integer num, if its prefix, if it's not only prefix number, if it's num is completely prime, if it's k prefix number and k suffix nums are all primes, else false. We need to return either true or false. So let's see what does it mean. So if you take number 23, num equal to 23. So prefix num, what are prefix nums? Like 2, comma 23. So it's like from left to right, it comes by digit appending. So the suffix nums here is as its anti-gravity suggesting it's 3, comma 23. Now both 2 and 23 both are primes, so this should be true. 3 and 23 both are primes, they should be true. Since this is true and this is true, the answer is true. We'll see a case where it fails. Num equal to, we'll take, let's say, take a big number, something 3896. What will be my prefix nums? It will be 3 comma 38 comma 389 comma 3896. No, why 2? It came 2. It should be 3. So similar way, suffix will be 6 comma, it's not 69, it should be 96 only. 6 comma 96 comma 896 comma 3896. Yeah, again same thing. All these four should be prime, then this should be true. All these four should be prime, then this is true. Then both should be and, should be like true and a true will be true. So that's all. I think this is a false because 3896 is not a prime. So the observation is like from left to right. Definitely you cannot like convert into string, iterate and keep appending like that, right? Because yeah, one thing is if you see the constraints are like 10 power 9. So even though int so let's say, okay, so num at least num in the sense like what's the maximum number of digits that num contains? Num may have at max 9 digits. So if you want to create an array which keeps doing this array appending like that, so you have to create 9 different string objects and keep appending them like string builder objects, and yeah, it's a bit headache. So that's not the actual intention of this problem. You can even solve by that, but that's not intention. So the intention is here to do this mathematically. How can we do it mathematically? So if you see, um, we can form this array by some logic, right? So I think this suffix nums is easy to form a logic. Suffix nums array is easy to form. I think it's just like modulo and division operator. And the prefix nums also, once if you see suffix sum how it forms, that's you can form that array. And if you have this prefix and suffix num, the solution is to iterate and check is prime for each and do and operation at last. Yeah, I think this is the, yeah, this should work. And what's the time complexity? Time complexity will be the number of digits, and space complexity will be like for 4-digit number, we are forming array of like 1 digit, 2 digit, then 3 digit, 4 digit. So for n digit number, we'll form array of size n. So it should be space complexity is 2n and time complexity is big of n, like where n is number of digits, and here it is 10 power 9. Should be good. Big of n is good. And one more thing is here checking whether a number is prime or not should be optimal. Maybe if you don't, if you usually in the CP questions, right, the mathematical questions, the prime number checking will be the common thing. So I don't say it's like remembering, but at one point of time you will memorize that, like how do you find the GCD of two numbers in optimal way using Euclid theorem. Similarly, you will get that uh, prime number ka logic in like by mind after solving some questions. So you have to use that because constraints are high. Normal medium algo can cost yearly time limit exceeded because of the 10 power 9 constraints. I'll show you the code. I can walk you through the code. So yeah, um, I created an array list and I appended the digits. So for example, in this case, we'll see how to construct this array. Now my digit array will be for number for num3896. For num3896, my digit array will be 3 comma 8 comma 9 comma 6, and I need to perform some operations on this array to make two arrays. Prefix num, suffix num. So like prefix sum will be like this, and previous number into 10 plus this, and the previous number into 10 plus this, the previous number plus into 10 plus this. And how will you come up with the suffix num? You have to see suffix sum you have to do in like ulta. So let's say now prefix sum is this, prefix num array is this. So initially the prefix num of 1 will be same as the digits of 1, so it will be 3. Now prefix num of 1 will be prefix sum of I minus 1 into 10 plus digit sum of 1. So the previous number 3 into 10 plus the current number that's there, which will be 38. Why it is coming? Yeah, which is 38. Now let me give some gap here so that now the previous number is 38 and we are at 9. So this number should be 38 into 9 plus 9, follows like this. Suffix num, okay, let me write logic for this. Prefix num of 0 equal to digit of 0. From I is equal to 1, right? I is less than n, say n is like digit dot length, I plus plus. What will be prefix sum of 1? Prefix sum of I will be, the present prefix sum will be prefix sum of I minus 1 into 10. Previous number we are multiplying with 10 and we are adding digit of I to this. So in this case we are adding 8 to 30. So that's why that's how the second number will become 38. And maybe you can do in the same loop, you can do suffix num, and I'm not like doesn't matter. So it's again same thing but in the reverse order, and this will be the pseudocode for that. Now you have two numbers and for each you have two arrays, and for each you see if not prime number the current suffix, like if here only you can calculate, right? If now first since we are already pre computing the prefix num of 0, here you can add one check if is prime of prefix, not this array, it's a function, right? So if he is prime of this number, then yeah, if not prime then literal false. If it is prime we cannot do, because let's say you are doing A and B. Why it came suddenly? So if you are doing A and B, this is false if either of A or B is false. You don't have to write about which case is true, because there are many cases where this is true and this is true. You cannot keep track of all that. So if this is false, we are returning false. Else we are not returning false. So yeah, I think that's how this question is an easy question. I was able to solve it in kind of 15 minutes. Not too fast, I know, but still. The prime number thing took a little bit time for me. So that's question number one. Let's copy this. Paste, 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 paste. Let's go to question three. I'll come back to question two because I was unable to solve question two in the time. So yeah, I think yeah, not bad. During contest, 37 people have solved this, and let's see what is okay topics. Another minute. What is hint for this? Let's see. Check primality for all prefix and suffix number return only true if one is prime. If everyone is prime, isn't it? This is actually a question. How is this is a hint because this is the summary of the question, right? This is what we have written here. If you see, this is what we have written here. Yeah, somehow sometimes it could surprise you. Yeah, we can go to question number three. Yeah. So maximize points after choosing K stars. This is the question. Let's read what question says. Yeah, I think I remember the question. Given two um, arrays of size n and also given k, you need to find score. But first k task should be done from nums1 itself. Remaining can be done from nums2. Okay, my bad. Okay, remaining can be done from nums2. Return max score. This is the question, right? Let's see an example key. Yeah, the array names are different. So the first array is technique 1 and first array is technique 2, but names doesn't matter, right? So for simplicity, let's take nums 1 5 to 10, nums 2 10 3 8, k equals to 2. Okay, k equals to 2. So first two tasks we have to pick from nums1 array, and since we need to return max score, so what we greedily thinks is greedily you can tell let's pick top k from nums1 and remaining n minus k from nums2. N minus k, remaining n minus k elements or points, sorry, not elements, from nums2. So this will return answer, but there is a small checkpoint for this. So it says um, okay, okay, so you have to pick any one of the index, right? So let's say if you choose 10, you cannot choose this 8 because you have choose 10 from this index. So it should be So it should be union. Is it union or union of indices picked is uh, 0, 1, and so on n, intersection of indices picked is 0. It should be null. So you know what I mean to say. So if you already picked index 2 from here, you cannot pick this index 2 because you have picked this from here. In that case, so let's say for greedily if we choose, we are picking 10 plus 5 from nums 1, and since we have picked 0th and first index, we are left with 3. So 3 from nums 2. So what will be score? Score is 15 plus 3, 18. But is this optimal? We'll see if we can get more score. So pick these two, 2 comma 10, 2 plus 10 from nums 1. And since you already picked 210, you cannot pick either of these two. You can only pick one because you already picked two, and only you can pick one big for you can only complete 10 tasks, right? And 10 from nums 2. Score is 22. Uh, let's go by same declaration. Score is 22. I think this is the most better answer, right? Let's see what they're expecting here. I don't know. Yeah, I think they're expecting 22. Same goes with this, and this you can just this if you understand one example. Yeah, I think you should understand the intent of the question. Okay, this question has higher acceptance rate than first question, which is surprising. Yeah. mm, so yeah, greedy doesn't work. Greedy doesn't work here. So even I have made a not a mistake, but I have made a blunder. Let's see how this made me to think in a wrong direction. Wrong direction. And can you tell counterexample for this? Is counterexample is a good word? Yeah, I think it's a good word. So what I thought was rather than showing, I can show you rather than telling. No question two I didn't do. Let's go to question. This question. So yeah. Um, so here in the small observation, I observed initially that greedy fails. But again, like I went in a direction key. We wanted to pick. We need to pick Pakka K task from nums one. But these don't need it to be max K tasks because it fails, right? We have just seen here. So we can still go through this, but when we have um, when we are at index I, say when we are at index I, so nums 1 I is less than nums 2 of I for the same index, then why will I pick nums 1? If I don't pick this nums 1, I can pick nums 2 in my n minus k operation. Let's not pick nums 1, rather we can pick nums 2 of I in next n minus k chances. So yeah, I thought this, like, create a priority queue, declare a priority queue, store nums1 comma index and order by nums1 of I descending order. This is what I thought. Once you order this, keep popping from queue, and you should not add to score obviously. Then for the index I, check if nums2 of I greater than nums2 nums1 is less than nums2 of I. If yes, then we add nums2 of I to score, because we are not picking the nums1 of I, we are picking nums2 of I, and this contributes to the n minus k chances, not the k chances. So yeah, this will be same. But yeah, I think this sounded nice, and I have written a pretty good code around this. I don't know whether it's correct or wrong, but I have written. And when I ran for a test case, it failed. I don't exactly remember the test case, because I have, when I ran it through my code dry run, it failed. And yeah, the fault is, if not k max elements, if not k max elements from nums1, what else you will pick from nums1? So it said that we have to pick k elements from this, and in the priority queue loop, you will run this while k is greater than 0 to pick first case to pick first k max elements. But when you skip one of them, when you skip one of this, how will you reorder pq? How will you reorder priority queue? You cannot reorder priority queue, right? Because you are okay, you polled it, and you observed that it's less than the adjacent array, and you omitted it. Now the next consequence elements will be less than k, and even if you pick all those the elements after skipping this element, you are not sure that you will complete k, because you already skipped some elements, and here is violating. And there is a good counter example where I failed, but yeah, I can show you that. I'll not having it in my submissions, because I haven't submitted that code. I just ran that code. So yeah. So now what is like observations? So this is the case. In order to pick top k, like there should be, okay, let's see in this way, right? So let's say I've completed all my tasks from using technique 2, second technique, and later I found out that moving from technique 2 to technique 1 is giving me a gain in the total score. Then I will move it, otherwise I will not move it. If I'm getting the negative gain, why will I move it? I will not move it, right? So it's simple. So does opposite works, like take take full score from first nums, then okay, I have to plug in my charger. 1 second. Yeah, I think, oh, it was 1%. Very good now. Yeah. So does that work? So assume initially I completed my task using nums1, and while shifting from nums1 to nums2, here I should lose it because only k I have to do. I cannot do more than that. So if I come from opposite direction, come from opposite, in this case you have control over choosing k task from stems 1, which gives you max gain, not max gain, not a mean gain. I think, yeah, I think once I iterate through this, you'll understand. So for gain, so you need difference, right? So create an array diff करके. So this is exactly, no, it's not nems 2 of I minus nems 1 of I, it's nems 1 of I minus nems 2 of I. So it's how much gain that it's different from nems 1, right? If it is positive, definitely nems 1 of I is greater than nems 2 of I, and we will go to that. We will go to it. So what is initial score? Initial score will be sum of all elements from nums 2. Now sort this difference in descending order. This is a method in arrays. B minus A. So this sorts in descending order. Mm, there is one. I think this is some comparator. I think, yeah, this is a comparator. Yeah, let's not go into it. Basically, it sorts the array in descending order. But if you put here A minus B, it sorts in ascending order. So yeah, that's how it works. B minus A, right? Okay. Now, for each, for first k elements, for first k, see if difference is positive. If difference is positive, we made a positive shift in completing the task. We made positive shift in completing the task. How do you revert back from this to another number? Since we already have a difference, which is diff, just add it to the answer. And what is answer? Answer is already sum of my this number. So it's like if I add this diff plus nums 2, it should become nums 1, right? Because yeah, it's so obvious because, one second. Yeah, it is so obvious because, yeah, he just now he saw diff I is equal to nums 1 of I minus nums 2 of I. So if you want nums 1 of I added to the answer, actual answer, just add a diff to the current sum. This is your current sum because you already have this nums 2 of I in your sum. So yeah, I think. So this you will do for first k. But see question carefully. Here also I messed up a little bit. And the question says you must complete at least k tasks using technique 1. At least k. If entire nums 1 favors, I will go with entire nums, right? Because I'm getting the maximum score there. If entire nums 1 favors, I'll go with nums 1, right? Because simple, again, more score, more points. So from k to n, collect all with positive diff. Yeah, I think, yeah, this is the, yeah, this should be good. Let me walk through the code. So I created an integer diff, and since the answer expecting in long, I declared answer as long variable. I'm adding initially with, I'm taking all the points from technique 2, and I'm calculating the difference array also. For the first k integers, we need to take diff irrespective of its positive or negative. Why? Because we must pick k, right? Irrespective of um, more score or less score. This is mandatory. That's why we must pick diff of I even though it's negative. So you can tell Jashwant after ordering in descending order, we got something like -8, -7, no, -9, -10. So you have to pick -8, right? Because you now you are in diff 2 and you have to pick k elements from this array. Let's say k is 1. You have to move from positive diff to positive score to this because you have to pick one. Maybe if this is 8 and if that is 10, and you should pick this because, yeah, because one you have to pick compulsory from this and you have to pick at least one maximum number from this. So yeah, um, that's why I'm not adding any of the condition. I'm just picking up first k. Later, why you can think after even picking up first k. That's I think that's complete the question, right? No, because the question shown, you can pick at least k. Minimum is k. Maximum you can pick all from nums one itself. So that's why I have loop from k to 1 to n. Now I'm checking diff is greater than 0 because now I have an option. I have already taken k elements. If I have the greater score in nums 2 rather than my nums 1 array, why will I go to nums 1? I'll not go, right? Only if it is positive and it's adding up to my answer, then only I will go. So that's why if you can see the check here, only if it's going if diff 1 greater than 0. That is when I'm adding diff answer this to the answer. Otherwise, I'm not adding. If you want little bit more efficient thing, you can do this. Why else break? This is a good point to observe. Why are my extra lines? Why else break? So so now we are after picking k, right? After picking k elements, we still see if I can still pick from nums one. If I cannot pick, if I cannot pick, that's good. If I can pick, I'm picking. When I cannot pick, so since diff is started and if you see negative, let there is no point of seeing this because our nums2 values are higher and we don't need regression, so we don't want our score to decrease. That's why you can break. I don't know if this might improve. Yeah, so let's say if your number of if the length is like 10 power 5 and from the second element itself you have yeah, this to be efficient so many conditions should be met. So yeah, just if you see this would have been commented earlier because it doesn't matter. So yeah, that is question 2 and this is kind of this I felt, yeah, bit tricky in the observation because you have to observe that you need to store the difference and you need to sort it in different descending order. That idea comes when you take the wrong step. So yeah, I think it's good to take wrong steps in contests. Let copy this entire line. Let's go to question 1. See, I wanted to discuss question 1. It given question 4 because of this pattern. After the dots, I have written question 3. Here also after the dots, it's expecting I'll go to question 4. But, okay, no, this. Let's see question one. This is no question two. Sorry, not one we have discussed already. This is a very good question. I like this question a lot. So let's close this. What is this question again? Okay, I think this I opened. It was during contest. I think. Let me check. Yeah, this was during contest. If you see, that's why it's Q2 and post contest. The questions will be converted into numbers. Yeah. So yeah, I remember this question very well. Given nums array, for each operation, you can increment or decrement array element by one. Why do we do this? Why we need to do this operation for making nums of I to nearest integer num, where binary representation of num is okay. No need nearest. No need. We'll understand why it's not needed. Okay, some spelling mistake. Okay, integer, integer. That's why. Yeah, yeah. Where binary representation of number is length of number is palindrome. So yeah, return um, minimum operations or yeah minimum number of operations. Return minimum operations. Understanding question. This took almost 4 5 minutes for me because you can see so many things in the question. So say given nums, let's see how many viewers we have. We cannot expect many viewers. But yeah, two people liked, and yeah, it's already yeah 1 o'clock, almost 1 o'clock. I cannot expect any of the viewers now. So yeah, where are we? Yeah, given nums, take it 12, take 4, take 2. Okay, is this example? No, but this is a good example. Yeah, this is a good example that I came up during contest. So take 12. What is its binary representation? 8400. And what is the nearest number to 12 that is palindrome in its binary representation? So something like 101. What is 101? 101 is 134. No, 012. 101 is 5. 1001. What is 1001? 1001 is 0123 8 plus 1 9. 1 1 is not because 1 1 is 3. 3 is not close. Out of all these three palindromic numbers, which is closer? 9 is closest. So, in order to make 12 to 9, it takes three operations. Because you can either decrement or increment, right? It takes three operations, and in order to make 12 to 9, it takes three operations. Correct. Now, why I told you this should be like this should be maximum. Why here I typed for making to nearest. Why did I strike this off nearest? Because they haven't given this in the question. Okay, they haven't given this in the question, and we need to observe this. Why nearest matters? We need to return minimum number of operations, and each number will return in a minimum. Like this is minimum, this is minimum, this minimum. So that's why adding up everything will be minimum. So we need to find a closer number to this nums, which results in minimum operations. That's why I written nearest index here. So it takes three operations, and let's see the second. Take four. What is four? 0, 1, 2, 1, 0, 0. So this is closer to 101 is 5. 1, 1 is 3. 1, 0, 0. 0, 1, 0. What is 0, 1, 0? Is 2. But 0, 1, 0 is not palindromic because you have to neglect this leftmost 0 after leftmost set bit, because I can add how many number of zeros. Like I cannot say this is not palindrome. If I can tell this is a palindrome, that same 2 can be written as this also. In that case, this is not a palindrome because yeah, I always have confusion like whether it's most significant or least significant. But yeah, in just to avoid that confusion, let's tell the zeros left side to the most leftmost set bit one are to be ignored. Yeah, this is done. So what we have to do is we have to somehow generate the palindromic um, the palindromic bits integers. We have to somehow generate these integers. Say we got list of this or array of these integers. Array of integers whose binary rep is palindromic. Now what we have to do for each num in nums, so what okay, so there can be a number which is greater than 12 and still palindromic. So I can tell 110011. This is also palindromic. 110011. This is also palindromic. But we don't know. We need to find the minimum difference between this number and these three numbers, and we need to take that as an answer. In this case, 9, not 11011. This is also an answer. This will also exist in this list. So we need to find this. So for each num in nums, find find the max number less than num. Find min number greater than num. So this is, I think this is also called as maximum number less than num, also called as upper bound. I am not sure, I'm very bad with terms. And this is also called as lower bound. Again, I'm not sure, just guessing because I don't know. I don't know. So what will be the answer in this case? So answer will be absolute difference of these two. Maths. Okay. Okay. Answer will be minimum of absolute difference of these two, upper bound and lower bound, because this is answer, right? And what is this number? If we can decode 3, 8, 11 plus 16, 27. This is a number and this is a number. Maybe this is the upper bound. This is the max number, or this is a minimum number which is greater than 12. Okay, so say for 12, 27 is upper bound, 9 is lower bound. 12 minus 9 is less than 27 minus 12, right? So that's why my answer is, because here I am taking 15 steps, and here I am, and here I am taking only 3 steps. Why will I take 15 steps if I can reach in 3 steps? Because we want a minimum. So this is what is the final formula, like, or like whatever you call it. But the tricky part of this question is how will you pre-populate this? And yeah, I couldn't do that in the given amount of time. How can you pre-populate this plandromic wala? That's what I fail to do. If yeah, I have to observe this. um, Maybe first I have to try in different way that I haven't done. Yeah, I cannot try it here because it's already late, and I think maybe I don't know how much time it will take. I cannot estimate it, so that's why. Maybe I have to see some other solution, or maybe ask Gemini how can I do that. First, if I come up with brute force way, at least how to do that, I can work on optimizing that. Yeah, I tried different ways to generate those palindromics. It couldn't. So that's why I stopped. Even after observing this many things in this question and coming up with this, and all edge cases, everything, I couldn't solve this question. If you see, yeah, I have written some things, and I have done other things which I have not written here, and I have written in a notepad to prove the things, but still I couldn't do it because of time constraints. Yeah, I think my stopwatch is good. Yeah, I think that's it. And this is a good contest, right? Because in this we there's nothing to learn, just some mathematical stuff. This has good things to learn, and that observation thing, this observation based problem. Wait, let's just write that, right, just for my analysis. Question one is mathematical, like not proper math, but basic math. Question two is again observations, and also simulation, not simulation, and also kind of, yeah, pre-population or compute, and also computation. Maybe if I would have seen this kind of pre-computation of making things like this with bits and stuff, maybe I would have got idea. Maybe I could have coded if I have seen this earlier. But bad luck. This is my first time seeing this question, this kind of question. Maybe this again, this question, this uh, populating or like creating the palindromic things might be very easy, but the overall point is like everything is easy until you come to that point. Until you come, no, once you reach that point, once you have got that, it's easy. And since I'm unable to observe that and unable to come to that, it's not easy for me, at least. Maybe it's easy for from others' point of view. So question three is again observation based. For this, either you should have done question like this in past, else same wrong approach, penalty. Wrong approach and penalty. Once you see penalty there, you will realize your approach is wrong. Then you reiterate through your approach to actually come to the solution. So yeah, it's a pretty good contest, and I solved only two questions. Yeah, so not bad. I think I really enjoyed this. If I could somehow would have come to this, maybe I would have pushed myself to 2000 or 3000 ranks ahead of mine. So yeah, I think that's it for this that's it for this stream. If you see rankings, I cannot show my rankings. So first question I did in 15 minutes, and second question I did in almost half an hour. Third question because of one wrong approach, and remaining more than 45 minutes, remaining more than half of the time, 40 minutes, I was just seeing how to code this, not even think about that. Think I could do it in 3 4 minutes, but code this, how to generate the palindromic things. And if you see the like almost 1500 people solved all the four questions, which is very good. But don't bother about others until you are not perfect. So still okay. I'm ending the stream.